So far, we've brought together SwiftUI, UI Image Picker Controller, and Core Image, but the app still isn't terribly useful. After all, the sepia tone effect isn't that interesting. To make the whole app better, we're going to let users customize the filter they want to apply, and we'll accomplish that using an action sheet. On iPhone, this is a list of buttons that slides up from the bottom of the screen, and you can add as many as you want. It can even scroll if you really need it to. First, we need a property that will store whether the action sheet should be showing or not, so add this to Content View. @state, private var, showing filter sheet equals false. Now we can add an action sheet using the action sheet modifier. This works identically to sheet and alert. We provide it with the condition to monitor, and as soon as the condition becomes true, the action sheet will be shown. Start by adding this modifier below the sheet. .ActionSheet is presented $showing filter sheet. Then a comment, action sheet here. Now replace the change filter button action with this, self.showing filter sheet equals true. In terms of what to show in the action sheet, we can provide a title, a message, and an array of buttons to show. These buttons work just like alert. We provide a text title and an action to run when it's selected. For the action sheet in this app, we want users to select from a range of different core image filters, and when they choose one, it should be activated and immediately applied. To make this work, we're going to write a method that modifies current filter to whatever new filter they chose, then calls loadImage straight away. There is, however, a wrinkle in our plan, and it's a result of the way Apple wrapped the core image APIs to make them more Swift friendly. You see, the underlying core image API is entirely stringly typed. So rather than invent all new classes for us to use, Apple instead created a series of protocols. When we assign CIFilter.sepiaTone to a property, we get an object of the class CIFilter that happens to conform to a protocol called CISepiaTone. That protocol then exposes the intensity parameter we've been using, but internally it'll just map it to a call to setValue4Key. This flexibility actually works in our favor, because it means we can write code that works across all filters, as long as we're careful not to send in an invalid value. So let's start solving the problem. Please change your current filter property to this, CIFilter. So again, CIFilter.sepiaTone returns a CIFilter object that conforms to CISepiaTone protocol. Adding that explicit type annotation means we're throwing away some data. We're saying that the filter must be a CI filter, but doesn't have to conform to CISepiaTone anymore. As a result of this change, we lose access to the intensity property, which means this code here won't work anymore. Instead, we have to replace that with a call to setValue4Key. This is all the protocol was doing anyway, but it did provide valuable extra type safety. Replace that broken line of code with this, current filter, .setValue, filter intensity, 4Key, KCI input intensity key. KCI input intensity key is another core image constant value, and it has the same effect as setting the intensity parameter of the sepia tone filter. With that change, we can return to our action sheet. We want to be able to change that filter to something else, then call loadImage. So add this method to Content View. Func setFilter, filter CIFilter, current filter equals filter, loadImage. With that in place, we can now replace the action sheet here comment with a series of buttons that try out various core image filters. Put this in its place. Action sheet, title, text, select a filter, buttons, an array of, .default, text crystallize, self.setFilter, CIFilter.crystallize, then edges, setFilter, CIFilter.edges, then Gaussian blur, CIFilter.Gaussian blur, pixelate, filter.pixelate, sepia tone, filter.sepiatone, unsharp mask, filter.unsharp mask, and vignette, filter.vignette. Now I picked out those from the vast range of core image filters, but you're welcome to try using code completion to see what else comes up. Type CIFilter dot and see what you find. Now go ahead and run the app, select a picture, then try changing sepia tone to vignette. This applies a darkening effect around the edges of your photo. Remember, if you're using the simulator, give it a little time because it's super slow. Now try changing filter to Gaussian blur, which ought to blur the image, but will instead cause our app to crash. By throwing away the CI sepia tone restriction for our filter, we're now forced to send values in using setValue4Key, which provides no safety at all. In this case, the Gaussian blur filter doesn't have an intensity value, so the app just crashes. To fix this, and also to make our single slider do much more work, we're going to add some more code that reads all the valid keys we can use with setValue4Key, and only sets the intensity key if it's supported by the current filter. Using this approach, we can actually query as many keys as we want, and set all the ones that are supported. So, for sepia tone, this will set intensity, but for Gaussian blur, it'll set the radius, i.e. size of the blur, and so on. This conditional approach will work with any filters you choose to apply, which means you can experiment with others safely. The only thing to be careful of is to make sure you scale up filter intensity by a number that makes sense. A 1 pixel blur is pretty much invisible, for example, so I'm going to multiply that by 200 to make it more pronounced. So, replace this line here with this. Let input keys equals current filter dot input keys. If input keys dot contains KCI input intensity key, current filter dot set value, filter intensity, for key KCI input intensity key. Next we'll look for the radius key, and if we find that, we'll set the value filter intensity times 200 for that radius key. And finally, if there's a scale key, we'll set our value to be intensity times 10 for that scale key. And with that in place, you can now run the app safely. Import a picture of your choosing, then try out all the various filters. Nothing should crash anymore. Try experimenting with different filters and keys to see what you can find.